privilege to warmly welcome you all to this seventh session of the Faculty Development Program. Today, we are honored to have with us Mr. Prateek Bansal, an accomplished professional in the field of medical imaging and healthcare technology. Mr. Bansal is currently serving as an application engineer in Immersive Medtech Solution, Gurgaon, Haryana. In his role, he has been actively contributing to the integration of advanced technologies in medical imaging and diagnosis. His expertise particularly spans across modern healthcare tools like Illusis by Realized Medical and Synopsis Simplified software, which are transforming the way medical professionals analyze and interpret complex imaging data. With his rich knowledge and practical insights, Mr. Bansal has been playing a key role in bridging the gap between cutting-edge technology and its real-world application in the healthcare sector. We are truly delighted to have him with us today, and I am confident that this session will provide us with valuable perspectives and hands-on understanding of this innovative software solution. On behalf of the organizers and all participants, I extend a very warm welcome to you, Mr. Prateek Bansal. We look forward to learn from your expertise. The session is yours, sir.
Hello, I hope I'm audible to everyone.
Give us a slide.
So, good afternoon, everyone. My name is Prateek Bansal, and I am an application engineer in integrated microsystem, Gurugram. I welcome you all, the faculty members and research persons who have joined here in this FDP session on advances in deep learning for medical imaging and disease diagnosis. So today in this session, I will be covering Synopsys Simpleware software, and my colleague will be covering Illusis by Realized Medical. So first, from 2 p.m. to 3 p.m., we'll be covering Synopsys Simpleware, and we have divided it into two parts. First is for presentation, and second is for live demonstration of the software. So let's start. I'm sharing my screen. So let's start. So what is Simpleware software? Simpleware software is a 3D image processing and segmentation software by which we can generate 3D models. We can do finite element analysis and computational dynamics analysis with the raw data of dichrome images that are CT scan, macro CT scan, and MRI scans. And it has complete capabilities of manual segmentations, auto segmentations, external model generation, and surgical cutting guides, and all the surface tools we have. We have all the possible import capabilities and all the export capabilities, and also we have a design link that can be integrated with SolidWorks for implant fitting and design. Further, after the process goes, the workflow goes like first we'll do our dichrome images. We import our dichrome images, and after importing our dichrome images, we get a window of all the patient data and everything else there. We can basically import that. And after importing, we have several options in our tools within that is pre-processing of images. So first task is our pre-processing of images. After pre-processing, we have segmentation task, which can be done with the help of manual segmentation or automated segmentation. Or we have a third option also, that is semi-automated segmentation. So basically, manual segmentation takes a lot of uh, time, but it is really like we can modify it according to our needs. We can uh, do custom segmentation with the help of manual segmentation. And we have auto segmentation, which already Simpleware has given us presets of pelvis data, knee data. I'm talking about CT scan and MRI scan. So knee data is there, shoulder data is there, craniomaxillofacial data is there, and in the cardiac section, we have heart data. So let's move forward. Let's now talk about the applications of Synopsys Simpleware.
देता है तो तुम्हारे काम कर सकते.
So first, it has orthopedics, which includes like all the pelvis data and etc., which we see in this session. We have biomechanics and consumer products applications also, which includes like stress and strain analysis, etc. We have cardiovascular and respiratory systems, which we can see in our heart data. It can also use in electromagnetics and neuromodulations. For example, if we are using an implant, a metallic implant, so it can basically analyze its properties, that how like the implant will heat or not, uh, and what is the capabilities of tissues. We can analyze that also. We can also integrate a device with the image. We have 3D printing preparation also. We can produce high quality STL models from here. Apart from clinical applications, it has materials and rocks applications also. In this session, we are talking about medical applications. This software currently given us a new version of 2025.06, which has a lot of new features. For example, bone filling filters are there. Spine CT auto segmentation it has given us. Hip revision CT auto segmentation it has given us for specifically for implant data. And it has given us mask similarity calculator to calculate similarity between two masks. Uh, it has also given us surgical cutting guide for specifically for surgeries on specific patient data, which allows fully customization of threads, pin, and drill holes in these components. So it also comes in a scan IP module, which provides us the environment of importing our 3D image data set, that is CT scan, micro CT scan, and MRI scans, which will visualize in three 2D views and one 3D view. And it has all the capabilities of this software, which are like FE meshing, NORS meshing, and its export capabilities. Here are the export formats of our scan IP module. First is import modules, which we can see it has DICOM images like DICOM images and also GIF, PNG, etc. Export we can export it into ANSYS, Abacus, and also raw images, XJPG, etc. Moving forward into FE module. So meshing will be covered in four parts. First is surface meshing. Uh, Second is finite element meshing. Third is computational fluid dynamics meshing, and fourth one is our uh, nodes meshing. So finite element we use it for like the stress and strain analysis, etc. And wait a second. Hello, I hope I'm audible now
Yes, sir.
with a better voice quality.
Yes, sir, you are audible.
Okay, okay. So we were talking about finite element meshing. So Simpleware offers us four different types of meshing capabilities, that is surface meshing, finite element meshing, computational fluid dynamics meshing, and noise meshing. Basically, finite element meshing helps us in generate high quality models that helps us in uh, further stress and strain analysis and other biomechanics analysis. It has various export format capabilities and for example, Abacus, ANSYS, LS-DYNA, COMSOL. Moving forward into nerves. So this type of meshing is called non-uniform relational B-splines. It basically helps in uh, CAD modeling that can be possible after importing, after exporting it to various kind of softwares, CAD softwares. It has capabilities to integrate the CAD softwares with this simple way with the help of internal structure wizards, etc., which further helps in 3D printing. It also has design link, as I mentioned earlier, with SolidWorks for uh, its implant integration. Let's moving forward into automated segmentation. So it generally divided into three parts. First is orthopedics. For orthopedics, we have auto segmentation of hip CT and then ankle CT. Then we have knee CT, knee MRI, craniomaxillofacial, spine CT, shoulder CT, and we have hip revision CT also. For cardiovascular application, we have auto segmentation of heart CT, heart valve analysis also. Then we have external model generation, which we can use for image processing, line marking, and measurements, etc. So basically, these automated segmentation, which Simpleware recently uh, given us, consists of a high level of deep machine learning and AI technologies, which uh, automates your segmentation with high precision and with uh, very less time. So it reduce manual work also. If you if you do not have to uh, manual segment any particular data, you don't have to work on the particular data for the whole day, we just click on auto segmentation. It has given us presets for varieties of parts. So you just have to click on auto segmentation and apply it. Segment all the parts within few minutes only, which manual segmentation does in hours of work. So AS also, we have options in CT and MRI. So for a hip CT, like we import pelvis DICOM, so it creates its segmented parts and split into regions like sacrum, right hip, right femur, left femur, and for knee also, femur, tibia, patella, fibula are also there. So you can see that is how it works. We'll see it in live demonstration. So we have ankle CT, knee CT, and so on. So you can compare it here, that how manual segmentation takes a lot of time, where automated segmentation does our task in a couple of minutes. Like it is taking 38 minutes to segment this data, but automated segmentation does this in 2 minutes and 2 seconds. Now we have cardiovascular section also in automated segmentation, where it very efficiently segment it all the parts like aorta, pulmonary artery, left ventricle, right ventricle, etc. You can see to manual segment heart, it takes around 4 minutes, and automated segmentation does it in 1 minute. You can see a full 3D printed heart, so we can export it like this. So here are some system requirements for this software. You can keep this in mind while installing the software. Let's moving forward into the live demonstration of the software. I'm currently showing the live demonstration of the software. Meanwhile, if you have any doubt, I'll give you time after the session to uh, resolve all your queries. So this is the graphical user interface of this Synopsys Simpleware version of 2025.06. It has a lot of variety of tools in its ribbon, like image processing. It basically used for pre-processing of images, and manual segmentation is also there. And a few things are of semi-automated segmentation are also there, like bone filling, etc. Here comes fully automated segmentation, where we have orthopedic, cardiovascular, and external model sections. We have surface tool options and so on. So let's import a DICOM image. So you have to follow this paths like Windows C, then program files, then synopsis, simpleware, version, data, or if you have any specific patient data, you can go to that folder. I'm taking this pelvis data. So after scanning, you just have to click on this folder on one time, and you have to click on select folder. So it showcases me number of images it has, frames it has, modality, and all the patient data is there. So this interface given us three 2D views with different axes Like this is coronal, this is sagittal, this is axial, and one volume rendering of this CT scan of pelvis. So let's expand this. Let's go into this image processing, which we are using for pre-processing of images. We have transform tools here, we have segmentation tools here, and we have additional filter tools here. So in transform tools, we have resample. Like resampling, currently it has data set memory of 68.57 MB. This resample tool will make your data upscale or downscale. Like it basically used when you have a large number of data set memory in your data. So you just have to downsample its image, and then the data will be like, for an example, currently I'm changing its sampling parameters. For example, so as you can see, so it upsamples our dataset memory of 523 MB, and we can see it here. Uh, it has increased our slices and doubled it. So let's just undo it. And we have this crop tool also here. If we want to select our region of interest, we can do it from here. Like this is perfect for me. Then I'll click on apply. So it has decreased my data set memory, and it will help in further processing. And we have different types of rescale, different types of transform tools like rescale tool to change its physical parameters, shrink left tool to uh, decrease the padding uniformly from all the sides. We have padding to increase the padding from all sides. We have aligned it with different data sets, and we have raised the data sets which we'll talk about in few minutes. Firstly, we will use the manual segmentation to segment this image. So we'll use threshold. So it has this grayscale values and this histogram. So what we basically does, we will go into presets. It has given us presets, simply given us presets for bone, muscles, fat, and skin. So currently I'm working on bone, so I'll select bone. So it has shown me the lower value 230 and upper value 3020. I'll click on this additional processing also to fill cavities and resulting mass, and only give the largest resulting island. Only give the largest resulting island will remove these kind of artifacts which are not connected to the larger island dataset. So it will create a new mask in output. I'll click on apply. For like to see our output, we have to click on this option, which is generate a fast preview. So we'll click on this. It has created a mask out of our raw data. So this is our mask. It is available in this dataset browsers. So from now we can further process it, like we can use 3D editing. We can use this. Wait. Suppose suppose we don't need this data, so we'll remove it from this 3D editing tool. and it is divided into two islands, which is basically a larger island and a smaller island. We can now use mask split fill option and click on this larger island to remove our smaller island from it. So now we have our clean data. We can now use split regions to segment out our parts like sacrum, left hip, right hip. And we in this split regions we have given presets option. We'll click on this hip part, and now to segment it out, we have to click this live 3D option. So now for selecting the hip left, I'll draw a boundary here. To select hip right, I'll draw here. For the sacrum, I'll draw boundaries here. For the femur, femur left, I see boundary here. Femur right, click on here. Uh, like preview, it has given us preview button. So as you can see, it has segmented out our all the regions. So now let's click on apply if we are fully satisfied with this output. So it has created a dataset memory of 194.52 MB after segmentation. So this was the manual segmentation. We can use semi-automatic segmentation also there. So we can use a bone filling filter from this additional tools. So let's do this on this femur right. We can also like isolate any particular region, any particular part to further work on it. We'll click on this, and to select the active mask, we have to just click on that mask, and we'll click apply. So it will fill any cavities inside this femur right, which has been left in manual segmentation. So as you can see, it is much better than before. Now let's take another example. So this was the manual segmentation. I'm taking now let's move forward into automated segmentation. So I'll click on another window of the software. We can open any number of windows in the system. So I click on icon images, scan folder, and the same process. Windows C, program files. We have this synopsis, simpleware, moving 5x, and then data. Since I've used pelvis for manual segmentation, I'll use pelvis again for the automated segmentation. I click on this, select folder, all the details, finish. It has given us similar user interface. We have this volume rendering of our pelvis. So I'll click on auto segmentation. We have three parts here. First is orthopedic. We have hip CT here. So I'll click on this. It has given me options to create landmarks and keep all known fragments. I'll click on both. It is used for further processing uh, to like click on this automatic shift region, and then I'll click on apply. It will take few seconds to segment this data. Then we will see all the examples from here, like ankle CT, knee CT, and we have craniomaxillofacial, heart CT, and we'll also see uh, heart beating animation from a patient data. Let's just wait till it's complete. It is almost completed. After completion, it will show us a summary in which all the parts it has identified. So let's just wait for that. It has also created all the landmarks which are necessary. So it is identified in the summary. So we'll click on this generate fast preview, and you can see how precisely it segmented the data. Let's move forward into implant fitting. So let's just isolate our hip, right? And we'll click on the surface tools. We'll import our surface. So we have this SEPETEMBER cup implant. We'll open it. So it has given us all the details of this structure, the surface, that number of polygons it has watertight or not, etc. So we'll click on this import. Currently, it is out of our region. So what we basically do, we will call this zero position, and we'll click on apply. It has already selected our active surfaces SWL cup. So it is now in the region. To set it here, our task is to set this implant here. We use this register dataset token, and we'll click on this SWL cup, and then we click on update. We click on next. In this registration method, we use automatic from DICOM. The dataset we'll use is hip right, and this we have to click on triangle selection. So basically, we have to brush our region here like this. Same for this brush, and we'll click on this blow selection, blow angle threshold. So we'll just touch on it, and it has brushed all the region. We'll click on this update. So as you can see, it is fitted, but it is still needs modification. We'll click on finish, and then we'll use this position and orientation. So we can see it is now correctly fitted. We can also like change the opacity here to see like it is correctly fitted or not. It is correctly fitted now. From now, we can see a few more options here. Like this software is vast. It has many tools that we cannot cover in a single session. Uh, let's just move into the mass generation. So I'll click on this surface to mass. Okay, let's just remove it. Let's just delete it. So we have this mass to surface, sorry. So we'll create a surface out of it. So I'll select hip right and generate a surface. So it is currently out of dated. So we have to click on this generate a fast preview to make it up to date, and then we'll click on generate. It is showing low quality generation. We have already uh, have fast preview of high quality. So we'll click on generate, and yes, it has created a surface out of it. We can see a lot of options here. Like we can use this internal structure wizard to see its internal. So it usually takes 3 tasks. Uh, as you can see from this view tool, we can see its internal. If I disable it, you can see in the internal structure. So let's just move forward. So we have this data. We can we have various options here. Uh, we can emboss text in this surface. So first we have to create surface, mask to surface. Right. Okay. Make a fast video. So like it is hip right. So I'll click on hip and see. Okay. From here I'll so I'll click on this generate, and then I'll click on this emboss text, and I'll click on this. Hmm. So from now, you can basically
set it like this, and you can click on apply. Hello, am I audible now? So as you can see, it has created a text in this part of hip right. Uh, so now let's see other things from here. So we have this proximal right also here. So let's from here in the measurement section, we can create center lines out of it. So let's just click on this. We have created center lines. We can see, we can edit its. From here we can move. We can also see cross section parameters of this femur right. So now let's we have this mass similarity calculator also, which generates dice score out of two masks. We have this 2D contours also, which we use to like calculate variety of calculations in the 2D viewers. So let's make model out of it. Since I'm using this hip right, I'll drag and drop into this model section with this 4 options to surface model, FE model, CFD model, NURBS model also. So I'll click on this finite element model. It has given us a separate ribbon for us. I'll click on this setup model. We have selected FE for it. It has various export capabilities in Abacus, Edina, ANSYS, etc. Since we have used automated segmentation, we don't have to we don't need this pre-processing of smart masking smoothing. We'll click on volume meshing. We have two algorithms here. First is FE grade and FE fill. In FE grade, we have this hexahedra, tetrahedra, linear, quadratic, linear, tetrahedra, and quadratic tetrahedra. In this free, we have all tetrahedral linear, quadratic and straight edges, quadratic and curved edges. It has also options for the mesh quality. We can also increase its coarseness value, decrease its coarseness value. For an example, I'm giving it 30. We can also change its quality from here. Moving forward into materials properties, we have this grayscale based material properties, in which we have this grayscales. Currently it is on Young's modules. You can basically drag into whatever modifications we need. It has also mass density grayscale values. It has frequency, grayscale frequency also. It has this calibration points also, which we can modify it from here. And also Young's modulus options. Let's see, I'll change its value from here. And after that, I can also save it. It has already given us that in.
कितने का आ रहा है वो?
And we have this context also. So we can click on this add possible context pairs. So it will add all the possible contexts from here. We click on shell, and similarly it will add all possible sets from here. We can have all the possible shells from here also. We can add, and we can also click on this mesh refinement regions for our, which we don't need now. We have this boundary layers option. We'll click on this hip right, and then we'll click on this. So it will generate all the information here. So from here, we can click on this segmentation quality to check our model is ready to. Uh, so it has no segmentation problems. If it has any issues, you can click on this fix problems. We'll close it. We'll click on this model preview, and after it, we'll go forward to full model generation. So it consists of 9 steps. So like it won't take much time. It usually completes in few seconds. So after completing, we can see it has generated a mesh out of it. We can directly export it from here. Similarly, we can create models for our surface computational fluid dynamics and knobs. Moving forward into more automated segmentation of different types of data. We'll go into Windows C. We'll go into program files. Before that, we can also check analysis out of it, like create more analysis. And this from we are currently using model, so we'll click on this model statistics, and then we'll click on this pore size, load template. We'll click on run analysis. So it will do all the analysis and shows the output in the form of plots. Let's just wait for it. Similarly, we can see to open like ankle CT, knee CT, knee MRI, we can use this open folder option or open project option, in which we'll go into Windows C. The same method we'll follow, and then synopsis, then simpleware, version, data, and here we have our ankle. You can click on this ankle. We'll click on this. No, we don't have to. We don't need to save it. Since it is processing, we are seeing auto segmentation of angle. From here, we use the same process, keep all one fragments, apply. Analysis has been successfully completed. We can see the statistics here in the plot section. You can see all the plots. So as you can see, this was the analysis. And you can perform all types of auto segmentations in this. So it has identified all the regions. I'll click on this. I'll click on fast preview. See how fast it is to segment out of auto segmentation. In future, we can have more sessions for this simple software, since in one session all the things cannot be covered. It has various kind of tools. One last thing I wanted to show you. I'm taking this example. So I hope I have covered uh, important things out of this software, which might be helpful in your applications. It will take time, but we are time bounded because from 3 p.m. we are having presentation of another software, that is Elucys by Realize Medical. It is a wonderful 3D image processing software which works on virtual reality, and we have to use a headset out of it. So it has processed this data. So we have this heart data of a patient. So we can see live heart beating out of it in this software. We can also auto segment it, and we can also see cleaned heart beating. From here we can use this, and we can click on apply. So I hope you all are clear with this Synopsys Simpleware. It's a wonderful software to manage all your applications. Let's begin with the Elucys. I have Ayush with me, my colleague from Immersive MedTech Solutions.
Hi, Prateek. Hi. Thank you for the presentation. I think there are a couple of queries in the chat box. I hope you will be addressing that. So the first one is it an open source software? No, so it's a commercial software that needs to be used for The recording can be given. That has been covered. Yeah. So I'm just sharing my screen. Just let me know if my screen is visible. I hope my screen is visible. Just minimizing this down. Yeah. So let me start. So this is Ayush. I'm an application engineer at Immersive MedTech Solutions. First of all, I would like to extend my gratitude to Dr. Praveer Kumar Shetty for giving us this opportunity to illustrate Elucys by Realized Medical in this esteemed FDP, jointly organized by ATAL. So in this session, I shall be covering out the transforming medical imaging into interactive VR using Elucys Next software. So it's just a short presentation. I will be much more focusing on the live demonstration, how to basically interact with the tool, how to basically navigate between the data sets, what are the different options that we can cater to. So starting up with the first presentation, to just give a general introduction, there is one important need to understand. We had the old 3D image processing softwares, then we had the 2D image analysis softwares. So why there is a need to switch on the particular area of interest to a VR? To answer that, it's a very simple and easy answer. So whenever we used to do the 3D image processing, our ultimate aim was either we needed to we were required to develop a 3D printable model so that surgical analysis can be done, pre-surgical analysis can be done, or same is the case with post-surgical analysis. But with the current need, with the current need of the softwares of the particular 3D printed model, it is not that feasible because recently we had printed a cardiac data set. So this was a patient that has a VSD defect, that is ventricular septal defect. Uh, so the main issue that we got was whenever we had done the segmentation, the surgeon has asked for a particular 3D printed model of the same. The printed model got destroyed in between of the 3D printing 2 or 3 times. So there is a specific need to reduce down our dependency on 3D printing. So this way, the VR segmentation has been introduced. We can directly do the segmentation in the 3D view itself. We can navigate between the slices. The slices are nothing. For example, if we are considering a DICOM, that is a medical image data, which can either be of the form of a CT image or an MRI image, what we can do is it is a stack of images. So for example, if we are considering, let me open a pointer. So for example, if we are considering, I think the pen is disabled, no issues. So for example, if we are considering a image, let us take this image only. So this is just a 2D view for us. We can only see the front to back view of this particular image. But to understand an anatomy, just to see a coronal view, a sagittal view, or an axial view, that is not sufficient. We need to have an accurate 3D representation of the same. So to cater that, either we can rely on the 3D image processing softwares like we have SimpleWare, which is a very good option, to be honest, because we can directly do the 3D image processing. And once the image processing has been conducted, we can slice and navigate through the dataset. If required, for example, for doing the research purposes, we can develop finite element models, computational fluid dynamics model, or NERVs model. It basically depends on our use case to use case. But for example, to do the pre-surgical planning, it is generally advisable to deal up with the image segmentation in the most faster and most accurate way. So to cover that part out, VR segmentation plays an important role. We can directly navigate, we can highlight the areas that we want, we can do further segmentation. And at last, one more thing that we already have the support in the VR is whenever we have developed certain model, even if we are required to do the 3D print of that, that can be done. We have the supported tools for that. That I'll further showcase in the live demonstration how to navigate within the dataset. So moving on to the next slide, a slight overview of how VR is playing an interactive role in medical imaging. So whenever we are saying that we navigate with the image dataset, so for a naive user, it may sound a little bit odd how we are navigating between the dataset. So what we generally have is when we are in a VR view, so we are seeing the particular environment in a 3D. So for example, whatever I see it's basically a 3D view representation of our surroundings. But whenever we are dealing with a software that is working on a laptop or a computer screen, so we are doing the work in 3D, but we are still observing the particular view in 2D. So to counter that, we have this VI-based segmentation wherein we can directly work in the 3D. We can navigate to the specific points. Certain times, if, for example, a point lies in both X, Y, and Z direction, as stated in the earlier presentation of simpleware. So it's basically each and every pixels combined together to form a 3D reconstruction. So whenever we are encountering this issue, we can navigate to the exact points. And even if there is a need of any implant or a stent model, for example, that can be done in a very interactive way. We can directly position the particular stent or implant, whichever is required for. Now, let us see how it basically looks like. So for example, whenever I load my data set in the VR view, so this is the view that we exactly get. So even if there is any implant that has been positioned, so this is a post-operation surgical planning that was to be performed. Here the segmentation was done, then the different parts are easily identified out, like the outer layer, the skin, then the muscular region, then the orthopedics region, and at last the particular implant that were present in the data set. So each and every part got highlighted out as a different structure, and then we can navigate, we can push in different surface from one position to another in a very easy and efficient way. This also further facilitated us with better decision making. So the surgeon can plan the surgery accordingly in a very non-invasive way. Then how we are interacting with patient data set, this is the most foremost important thing. So whenever we are opening, for example, this data set, let me magnify the particular slide. So this is what view we actually see in the VR headset. So here, whenever we are working with the image segmentation, it is basically based on a threshold value. So whenever we are dealing with a threshold based segmentation, here we set out a grayscale range. Grayscale range being nothing, just the Hounsfield units of the dataset that we are working on. For example, if it's a 16-bit image, so it will have a grayscale coding from 0 to 255. For example, if it's a, for example, if it's a 8-bit image, it will have 0 to 255. If it's a 16-bit image, it will have from 0 to 65535. So this is how the grayscale range actually varies. We can basically change the image type also, rotating, integer, whichever is required. So this is much more on the basic image analysis that we perform. But the next part being the Hounsfield units. So as an engineer perspective, what we can understand by Hounsfield unit or by grayscale is the contrast change. Each and every part has a different set of contrast value. For example, if we are segmenting out a cardiac data set from a whole orthopedic region, so the cardiac data set, if it's a CT angio, the computed tomography of angio, CT angio that we are having, if we are dealing with that, so it will specifically highlight the particular heart region for us. And once the region has been highlighted out, the segmentation is very easy for us. Then, for example, the right now in the slide, we can see our rib region, that so whole rib cage is visible, then the shoulder bones are visible. So whenever we are dealing with data sets, so we can easily navigate out, we can easily highlight out different parts in the medical data set. And once the isolation has been carried out, we can work on specific part that is required for our region of interest. Now, coming back to the slides, let me just, so coming back to the slide. So there is one more question that everyone might be using some of the other method to do the segmentation, to do the integration with the existing system. So how is the compatibility in this Elucys by Realize Medical? This is a very genuine question to be concerned of, because whenever we are working, we are familiar with the old systems, old software, so we need to have a better and fuller.
His voice is not coming.
Hi, am I audible now?
Yes, sir.
Sure. Sorry for the. Yeah. So what I'm saying is, just give me a second. Sorry for the disturbance. So what I'm saying is, there is a need to understand how the integration works in the various systems. So what we actually get is when we are dealing with any data set, we can directly bring out in the STL files. We can also bring nifty OBJ images or even any DICOM, CT, micro-CT, MRI. Then it has a large number of benefits ranging from healthcare professions to researchers to directly work across DICOM dataset in a very easy and efficient way. I'm just covering the presentation faster because we have the time, we have limited time to show the live demonstration. And I think that would give a better understanding of the software. So dealing up with a real world application, it would be much more easier to directly show in the software how we are dealing with the real world applications, how we carry out the modeling, and how any surgical planning is to be performed. So I'm just, without any delay, I'm just switching over to the live demonstration of the software. So to open that, just minimizing this presentation. Yeah. So whenever I need to open Elucys, I'll just select on Elucys Next. And once the Elucys Next has been selected out, it will open the software view. There might be a little lag because there's some network connectivity issues at our end, but I hope it won't cause much problem. And after this, I also have a dedicated training session of the Elucys Next that I can provide if anyone is interested in software, how to do the basics of image processing, to understand the basics of image processing. Everything is covered out in that. So coming back, so let us see how we can create any image dataset or work on the existing dataset. Before that, let me show how the particular headset looks like. So I'm just switching on my camera. I don't know whether my camera is on or not. I'm just checking. Yeah, I hope my camera is visible. So this is how the VR headset looks like. Here are the left controller and the right controller that we have through which we navigate across the software to navigate across the data set that we are working on. So to operate on it, it's a very easy task. First we do is we click on create. Once we click on create, we get a option to import the data set, right, being a CT, MRI, to blend the particular data set. Or also we have certain other options. For example, these are the existing projects that I'm currently working on. So this is one such with an implant data set. It is a DORA case that is being worked. This is a TAVR case that is being worked on. It being a BST defect that is being worked on. This being a fractured mandible. So there are multiple image modalities. We aren't just limited to any specific orthopedics part of cardiovascular part. We do cover majority of all the anatomy that is being present. Just to showcase with a normal example how to import the dataset, what we need to do is we need to select the path that has our DICOM files. So this can be a good example. This we have recently acquired. So it's a live patient data set that we are required to do the 3D printing for. So before that, how to generate a 3D printable model? We just click over here. We select out the DICOM files.
ఎటువంటి ఎవరైనా వెళ్తాను సో నేనే వెళ్ళి మేడంతో మాట్లాడతాను పోయినా ఫోన్ పెట్టికి సో ఏం చేస్తాను ఏం పెట్టలేదు సార్ నీకు వెళ్ళరా క్వీన్స్ వస్తున్నారేమో అనుకున్నాను లాభం ఉంది మార్నింగ్ 3 hours సరే సరే లోపల నేను పోతా ల్యాబ్కి నాకు మార్నింగ్ 3 hours 3 hours నాకు తల బట్ట కట్టుకుపోయింది సరే ఇంకొచ్చి రండి అనేసి హార్ట్ మేడం తీసుకొస్తాను
Can you please like
kindly mute all of you, please.
thank you sir, thank you.
Yeah, now I hope I am audible. So to open any data set, so I'll just quickly show two data sets how we can work and navigate around the data set. Whenever we are importing a DICOM image, we just need to click over here and we can directly import the particular file and project folder that has the image data set that we need to work on. So whenever we are selecting a folder, we just need to select a folder like this. Now it will find out all the particular series, because whenever we are dealing with any DICOM data set, it is not just limited to a specific series of data set. Whenever data set is generated either from a GE machine or a Philips machine. We have a Siemens machine. We have multiple series of data set that we need to work on to do the segmentation. So the series might be a 4D image data set. So 4D data set is also supported. 4D is nothing but time offset integrated CT dataset that we are having. These are all the series of dataset that we have in this folder. So these are multiple series corresponding to which we can work on the dataset. So for example, this is primarily focused on the actual view comprising of 78 slices. Then we have the actual view with 467 slices. So we select whichever is the best one to the segmentation for example, and in analysis, we can select multiple series at once. For example, if I'm taking this as primary and this is secondary, we will later on get the option of fusing this dataset. The fusion of dataset will play a crucial role, especially when we are working with any CT and MRI dataset. So if there are two different modalities, if we need to integrate that, this plays a very crucial role. We can directly do the blending, and it's a seamless blending. It is not just a normal regular registration of one data set over other. We have a dedicated multiple algorithms to blend out different CT with MRI data set. So once this is opened, so now let me show how to open this particular view in the VR. So I'm just turning on my camera. Yeah. So whenever I am just navigating with my headset, I have got the particular view automatically in my VR headset. Now what I need to do is I need to first click on this follow point of view. So now whatever I would see in my VR headset, you would be seeing the same in your window right now. First of all, the foremost thing is to select our right controller. So before that, let me just enable quick tool tips so you can basically know what are the different buttons in a controller for. So the first thing that we need to do is we need to press the B button, that is the stylus modes option. And here we need to select the option. So we will get a view directly in the VR view, which other option we need to select. So the first one that we need to do is we need to click on this quick surface. Once the quick surface is done, taking one hand distance from our end, and we can just place the data set. So this way the data set can be loaded. I'll just lower it down. And this is how we can navigate between the data set. This is our ghost view. We can rotate it in all the particular 6 degrees of freedom. The data set, we can do the reslicing of this data set. We can select this particular structure. We can set it as movable. We can change the dimensions. In the left-hand tab, let me just again open the tooltips option. Here we are given with multiple options. So if I select this menu option, or even if I select this grab this particular navigation, so what I can do is I can increase and decrease the size. So even if we need to increase the particular window of our workspace, that can be done. If we need to reduce the size, that can be done. If we need to move it around the window, that can be done. If we need to rotate around a specific axis, that can be done. Similarly, around the other axis, it can be done. So these are the multiple options that we get. And this being the ghost view. So this is our actual working window. And this being the ghost view that we would be seeing. Ghost view is nothing, just a volume rendering that we were referring in a simple way. So for example, now I need to do the segmentation, start up with the segmentation. What I need to do is I need to click on this menu. Yeah, so I just need to click on this menu in the left-hand controller. And here I just need to select on models, addition of models, then clicking on create and selecting the structure as 3D. Now our basic purpose starts to do the image segmentation. Like we had done a threshold-based segmentation in simple way, we have the same over here. Since I have already created a model both in the 2D and 3D view, I just need to click on this right controller B button. Then I need to click on add. And once this add is created, you can see there is a panel that has opened in front of me. So it's an image threshold panel. Here we need to select all the 3 options on. And now we set in a threshold value for which we need to do the particular segmentation for. And whatever region that you are seeing right now covered in the pink region is the region that would be getting segmented out. So increase and decrease the brush size, we just need to move the right controller forward and backward. And according to our specific dimensions, we can start doing the particular segmentation. Now to start up with the segmentation, since it's directly done in 3D, either we can do it like this. We can also increase the size. So whatever region that would be lying in threshold will automatically get covered. So you can see in a fraction of seconds, any complex data set uh, gets just modeled out. So it hardly took some seconds of time to do the image segmentation. And this is directly done on the DICOM data set itself. So there is no issue of the data being improper or not. But there are certain concerns also that it has also highlighted some of the regions in the rib cage which weren't required for our end. So what we do for such cases is we had earlier on clicked on this add option. We also have one more option as subtract. So we'll just select the subtract option. And now whatever region that we would be selecting, we're selecting the subtract. And then we can reduce out this. Here the option has been selected as disk. Now I'll just select it as a sphere again, reduce out the size, and this way we can remove the non-required regions directly in the VR view. So this is how it is done. And one more advantage that we get with this VR-based segmentation software. So if we aren't required to do the segmentation in VR, so we are also supported by a desktop mode of segmentation. So we can select either of the method to do the segmentation for. Here we can just select and unselect the regions that aren't required. So we can directly cut them off. And once it is cut, we can easily navigate between the data set. And this way, in some fraction of seconds, we have got our desired heart structure. But some might still wonder that it is still the structure that outer structure, it's just for visualization of outer entropy. So that's not the case whenever we are dealing with 3D printing and all. So what we need to do is we need to convert it into a 3D printable model. So for example, when I was removing this region, so some of the region of my desired region also got removed. So for that, we have an option of growing. Here we move on to the specific part, and then we can slowly grow the particular region on the basis of threshold. So we select it over here, and this way only the required region would get minted. It takes some amount of time, but the output result is quite accurate. In this way, we have done a clean mode to perfect segmentation of the data set that we earlier used to rely on, the manual segmentation or the automated segmentation outputs. So this is very much easy. Now, for example, if I need to slice through this image data set, so I have an option that I can select the planes option on. Here, selecting a clip plane. So this was the plane that I was selecting. I'll just toggle that off. I'll select it in a new plane. And now we can slice through the image to see between the data set. But there might be a question that even if we are clipping, we aren't able to see the other data set to the other side. So what we'll do is we'll just click on this planes. And now when we are navigating with the data set, we can just click over here and we can move the particular clip plane accordingly. So this can be done in a very easy and efficient way. We can just navigate between the clip points. We can have multiple clipping options. So we can either clip it this way, clip it that way, and we can see the specific defect region. One more option that we can do is we can mirror this particular data set around this particular clipping region. To do that, we need to just click on operations. Here we have a clip plane operation. We can hollow the surface out. We can just split the particular region. We can mirror it out. So there are multiple options that can be performed. For example, if I just need to create out a hollow model, so I'll do is I'll just delete this particular clipping region, going to the operations, clicking as a shell operation, and taking the particular length. So 1 millimeter is completely fine. Once it is done, what it will do is it will automatically hollow this out the structure by 1 millimeter of wall thickness around every size. So once it is done, we can just now, what we can do is we can navigate between the data set, and we can see the different regions that are to be modeled. So I'll just disable the old one. And now if I use the planes option, clipping plane, new plane I have taken, for example. Now when I will clip this out, so you can see a clear hollow structure to be observed. So this is the particular defect area that we can see. So the particular had a VSD defect, and you can see VSD is basically a hole in a heart, as we say in general terms. So this way the region can be identified. And now if we are required to design a waffle or an object, so that can also be done. We have designing tools. We just need to go in the design tab, click on edit, and we have a create new option where we can directly select a surface, initial thickness and all is fine. Now we just highlight the point corresponding to which we require. So this way, any baffle or implant can be designed and positioned directly, which can be further converted. Once it is done, we can convert to structure, and this has created a separate structure that can be outputted as a STL file for doing the 3D printing. So this way, we can easily navigate. There are a lot of tools to be covered. It's quite difficult to just cover it in a 15-20 minutes presentation and demonstration. But it's a wide range of tools that can be navigated to. Similarly, I'll just show one more case of orthopedic data set that I had worked that has implant also pre-positioned in it. So I think it's somewhere on this one. Let me open. I need to check. Deleting the place. No, this isn't the dataset. So this is one such another dataset that I was recently working on. It has a tumor. So it had a kidney tumor to be present, which needed to be segmented out. So it was, let me show through volume rendering. This was the dataset that we were working. Here we have multiple volume rendering options that can be selected out, clicking on CT soft tissue. So this was the exact part that was having the particular tumor. We needed to identify the exact length of the tumor, and furthermore, for correct out it through surgery. So this is one such part. I'm just not getting where's the data set with the implant preposition, but I can show another one that is a fractured mandible that you had earlier on seen in simple way. So this is how the particular segmented model looks like. I'll just click over here. So this is also a segmentation that was performed within around 10 to 20 seconds. So it hardly took 10 to 20 seconds to model out this anatomy. And later on, the corrective parts were done. Then we can also create the connectors between the parts if required for the 3D printing, and multiple options. So this is a general overview of what can be done in the VR section. I'll just switch over to what all is possible in the particular desktop version of the software. So these are the desktop capabilities that we have. We can import any type of STL files. We can import any type of OBJ files, Nifty images. Then we can also do the exporting of structures as STL. So there are multiple options that can be catered. All the image segmentation that we have performed in VR, the same, we have the capability to be directly done in the desktop version also. So this is our general overview. Then we can record we can create the snapshots, then then we can do content recording, adding memo. There are multiple options that can be done. So since we have very limited time, I'm just opening the session for question answer. Anyone has any queries, please let me know. Also, I can just share some of the full length lectures of the training sessions that I recently provided in one of the institutes. So in that way, you can better understand about the Elucys software that we have. Please, any questions, anyone, whether being of simpleware or Elucys, you can ask.
Is this software used in any medical sector anywhere?
Yeah, it's being used, sir, for doing the pre-surgical planning. Then also it's also been used for doing the research works, like to design any prosthetics and all. And apart from that, to check the wear and tear over a period of time of any prosthetics. So this is very much needed. Almost every major hospital is using the software.
Thank you.
Yeah.
Any other queries?
Oh, any more questions? Anyone?
Any other queries? Okay. Thank you so much, Mr. Prateek and I Singh. for your insightful session and advanced medical engineering tools. We sincerely appreciate the time and effort you took to be with us today, and your contribution was truly added immense value to this FDP. Thank you once again, sir, for your
Thank
valuable
you.
knowledge and being
Thank you for
a
the,
part of this program.
Thank you, sir.
Thank
thank
you.
you, sir, for the session. Yeah.
Thank you for the session.